For problem number 15, we are given f of x is equal to 2x minus 3 all over x plus 1, and we're asked to find the inverse function. Well, step one is wherever there's f of x, we need to replace that with y. So my next line will be y is equal to 2x minus 3 all over x plus 1. Step two, wherever there's an x, I'm going to swap that with a y. Wherever there's a y, I'm going to swap it with an x. So this now becomes x is equal to 2y minus 3 all over y plus 1. Now the next step, 3, is I have to solve for y equals some stuff. Okay, so now this is not easy. If I let x be x over 1, I'm going to cross multiply x times y plus 1, right? This is how you cross multiply, right? And then 1 times all this stuff. So you set it equal to that. Well, 1 times that stuff was just 2y minus 3. Okay? And so then what I need to do is I can distribute the x through the parentheses, and I get xy plus x is equal to 2y minus 3. And my goal is to get y by itself, right? And all the other stuff on the other side of the equal sign. So I'm going to subtract 2y from this side and subtract 2y from this side. And I get xy minus 2y plus x is equal to negative 3. I'm going to isolate the y by subtracting x from this side and subtracting x on this side. And I'll get xy minus 2y is equal to negative 3 minus x. Okay. Then what I'm going to do is I'm going to factor out a y that leaves me with x minus 2 and set that equal to negative 3 minus x. Divide both sides by x minus 2, and I get y is equal to negative 3 minus x all over x minus 2. That is f inverse of x. Let me double check in my fancy book. I'm pretty sure that's right, unless I made a little mistake. But I never make mistakes. Yeah, in the back of the book it'll be written a little differently, but it's the same thing, it's the equivalent. In the back of the book what they did is they factored out a negative 1 in the top, so it was like negative 1 times 3 plus x, and then if you factored out a negative 1 on the bottom you would get 2 minus x, and so that's the answer they had in the back of the book.